Milk. It's nature's perfect food, or so we're told, but it has one major, glaring flaw. It goes bad. And, fast. This is because milk is mostly water, and where there's water, tiny microorganisms like bacteria love to throw a party. Without refrigeration, which is honestly a very new invention in the grand scheme of human history, fresh milk becomes a ticking clock. For thousands of years, people needed a way to preserve this incredibly nutritious liquid gold so it could be transported over long distances or stored for lean times. The challenge was simple, yet monumental. How do you get rid of the water without destroying the good stuff left behind? The quest to make milk last is not a new one. In fact, it's an ancient culinary puzzle. Historians tell us that Mongolian warriors, as far back as the 13th century, were masters of milk preservation. They would take milk, often from their mares, and dry it under the sun until it formed a thick, concentrated paste. This wasn't exactly the fine powder we know today, but it was a revolutionary concept. By removing the water, they effectively put the brakes on spoilage. This nutrient-dense paste could then be carried on long journeys, ready to be reconstituted with water to create a nourishing drink, providing vital sustenance far from home. This ancient ingenuity laid the groundwork for what was to come. For centuries, the idea of dried milk remained a rustic, manual process. It wasn't until the 19th century that science really entered the picture. In 1832, a Russian chemist named M. Durov figured out how to use heat and evaporation in a controlled way to create a stable, dry milk product. The Industrial Revolution then took this laboratory idea and scaled it up, paving the way for the mass production that would change how the world consumes dairy. Milk was no longer just a local perishable good, it was on its way to becoming a global commodity. Today, powdered milk is an unsung hero in our global food system. It became critically important during wartime, providing essential nutrition to soldiers on the front lines when fresh supplies were impossible. It's a cornerstone of humanitarian aid, delivering life-saving calories and protein to regions affected by famine or natural disasters, where refrigeration is a luxury. Beyond these critical uses, it's a secret ingredient in many of the foods we eat every day, from creamy chocolates and decadent ice creams to infant formulas and the simple convenience of a boxed cake mix. It's milk, just without the expiration date anxiety. The journey from a dairy farm's milking parlor to the can of powdered milk in your pantry is a marvel of modern food science. It all begins, as you might expect, with fresh liquid milk. But not just any milk will do. Large tankers collect raw milk from numerous dairy farms and transport it to a processing plant. Upon arrival, the milk doesn't just get waved through the door, it has to pass a series of rigorous tests. Technicians in a lab will check it for purity, ensuring it's free from any contaminants, and analyze its composition, measuring the precise levels of fat, protein, and other solids to guarantee quality and consistency. Once the milk gets the green light, its first stop is pasteurization. This is a crucial safety step, named after the famous scientist Louis Pasteur. The milk is quickly heated to a specific temperature, usually around 72 degrees Celsius, that's 161 degrees Fahrenheit, for about 15 seconds. This quick blast of heat is just enough to eliminate any harmful bacteria that might be lurking in the raw milk, like Salmonella or E. coli. The process is carefully calibrated to kill the bad guys, while preserving the valuable nutrients and the fresh taste of the milk. It's a delicate balancing act that makes the milk safe for the next stages of its transformation. After pasteurization, the milk moves on to a stage called standardization. This is where the milk is tailored to become a specific type of powder. A centrifuge, which is a machine that spins at incredibly high speeds, is used to separate the cream, the fatty part of the milk, from the skim milk. If the goal is to make whole milk powder, some of that cream is added back in to reach a specific fat percentage. For skim milk powder, nearly all the fat is permanently removed. This step is all about control, ensuring that every batch of powdered milk has the exact same nutritional profile and flavor as the one before it. With the milk standardized, the next major goal is to get rid of most of that water. This happens in a giant piece of equipment called an evaporator. Inside, the milk is heated gently under a vacuum, which lowers the water's boiling point. This allows a significant amount of water to turn into vapor and be removed without having to cook the milk at a high temperature, which would damage its flavor and nutrient content. The milk that comes out of the evaporator is a thick, concentrated liquid, almost like the consistency of condensed milk. About half the water is now gone, preparing the milk for its final dramatic transformation. Now for the main event, the part of the process that performs the real magic spray drying. The thick concentrated milk from the evaporator is pumped to the top of a massive silo-like chamber called a spray dryer. This chamber can be several stories high. At the top, the concentrated milk is forced through an atomizer, which is essentially a nozzle that sprays it out as a superfine mist of millions of tiny droplets. This mist creates a huge surface area, which is the key to what happens next. It's like turning a bucket of water into a cloud, making it much easier to dry out quickly. As this fine cloud of milk droplets falls through the spray dryer, it is met with a powerful blast of very hot, dry air. Heated to temperatures between 150 and 200 degrees Celsius, or 300 to 400 degrees Fahrenheit, the heat is so intense that the water in each tiny droplet evaporates almost instantaneously in less than 30 seconds. Because the evaporation is so rapid, the milk solids themselves never get hot enough to burn or scorch. The water vapor is whisked away, and what's left behind are microscopic particles of dry milk solids, which gently fall to the bottom of the chamber as a soft, white powder. The newly created milk powder is still warm when it collects at the bottom of the dryer, so its journey isn't quite over. It's immediately moved to a cooling system to bring its temperature down. If it were left warm, the powder could clump together and its quality would degrade. After cooling, the powder is sent through a series of sieves. This acts like a giant sifter, ensuring that the powder has a perfectly uniform and fine texture by filtering out any larger particles that may have formed. This step is critical for making sure the powder will dissolve smoothly later on. Finally, the finished powder is ready for packaging. For some products, an extra step called instantizing is performed. The powder is lightly re-moistened with steam and then re-dried, which causes the fine particles to stick together into larger, more porous granules. These granules dissolve much more easily in water, which is why it's called instant milk. The powder is then carefully weighed and sealed into airtight containers, like cans or multi-layered bags. Sometimes nitrogen gas is used to flush out all the oxygen before sealing, which further protects the powder from oxidation and extends its shelf life for years. Not all powdered milk is created equal. When you see it on the shelf, you'll notice a few different varieties, and the main difference between them comes down to fat. The most common type is whole milk powder. This version is made from milk where the fat content has been standardized to mimic that of fresh whole milk, usually around 26% fat by weight. This fat gives it a richer flavor and a creamier texture when reconstituted. It's often the preferred choice for baking or in recipes, where that creamy mouthfeel is important, but its higher fat content means it has a slightly shorter shelf life than its leaner cousin. On the other side of the spectrum is skimmed milk powder, also known as non-fat dry milk. As the name suggests, this is made from milk where nearly all the cream has been removed during the standardization process. The resulting powder has a very low fat content, typically less than 1.5%. Because fat can go rancid over time, skimmed milk powder boasts a much longer shelf life than whole milk powder, making it a favorite for long-term food storage. While its flavor is less rich, it provides a great source of protein and calcium, and dissolves quite well, making it versatile for everything from adding to smoothies to baking bread. Beyond the two main players, you might encounter other powders on the dairy aisle. Whey powder, for instance, a fascinating byproduct of the cheese-making industry. When milk is curdled to make cheese, the liquid left over is called whey. This liquid is rich in high-quality protein and can be dried into a powder using the same spray-drying method. Whey powder is a staple in the world of fitness and nutrition, forming the basis for most protein shakes. It's also used as an additive in many processed foods to boost protein content and improve texture, proving that in the food industry nothing goes to waste. Lastly, it's worth mentioning non-dairy creamers. While they often sit right next to powdered milk and serve a similar purpose, whitening your coffee or tea, they are a completely different product. Most of these whiteners contain no dairy at all. Instead, they are typically made from vegetable oils, corn syrup solids, and a variety of stabilizers and emulsifiers. They are engineered to mimic the look and feel of milk but are a product of food chemistry rather than dairy farming. So, while they might look the part, they are not in fact powdered milk. Read the label. It's always your best guide.